Today I am going to discuss about the basic proportionality theorem. In the last class we discussed about the similarity of two polygons. There are two conditions for similarity: all the corresponding angles are equivalent, all the corresponding sides are in the same ratio for the polygon having same number of sides. Now let us check the similarity of triangles. Here you have two triangles ABC and PQR. Since triangles are also polygons, you have to satisfy two conditions for similarity of triangles. First one is their corresponding angles are equal. That is two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Here in triangle ABC and PQR, if these two triangles are similar, you can say here angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. That means the corresponding angles are equal and their corresponding sides are in the same ratio or proportional. That means AB by PQ is equal to BC by QR is equal to AC by PR. If these two conditions satisfies, any triangles can be similar. If corresponding angles of two triangles are equal, then the triangles are called equiangular triangles. Here in these two triangles, angle ABC and angle PQR, angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. Therefore, triangle ABC and triangle PQR are equiangular triangles. There is a famous result on these equiangular triangles. This is a famous Greek mathematician Thales, who gave an important truth relating two equiangular triangles, which is as follows. The ratio of any two corresponding sides in two equiangular triangles is always the same. It is believed that Thales had used a result called basic proportionality theorem for proving the same. So this is also called Thales theorem. Now let us see what the basic proportionality theorem or Thales theorem is. Here is a triangle ABC. Let me draw a line parallel to BC. The line parallel to BC intersecting the other two sides of the triangle in distinct points D and E respectively. Then it divides the other two sides in the same ratio, that is AE by EB is equal to AD by DC. This is what basic proportionality theorem is. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Let us check it. Here AD is equal to 3.04, DB 4.2, AE 5.4, EC 7.46. Now let me find out AD by DB. AD by DB is equal to 3.04 by 4.2, which is equal to 0.72381. That is equal to 0.73723 corrected to 3 places of decimal. Now let us see A by EC, that is 5.4 divided by 7.46. That also equal to 0.723861, that is 0.7238. 8 correct to 4 places of decimal. Here corrected to 3 places of decimal, you can write it as 0.724. That means in all the cases, if you divide, you will get the same ratio. This is what basic proportionality theorem is. Now let us see how to prove this one. Here, given a triangle ABC and a line drawn parallel to BC intersecting the other two sides at D and D respectively. This we can write first as given. That is a triangle ABC in which a line parallel to side BC intersect the other two sides at D and D respectively. Now what we have to prove? You have to prove AD by DB is equal to AE by EC. Next we have to write that. Now to prove this one, we need a construction. That means join BE and CD. Again draw a perpendicular EN and on AB and DM on AC. Let us draw it. That is construction, we can write it as join BE and CD, then draw DM perpendicular to AC and EN perpendicular to AB. Now let us prove this one. Here is a triangle PQR. I want to find out the area of this triangle PQR. You know how to find out the area of a triangle is. Area of a triangle is equal to half into base into height. Now let me take QR as the base and let me draw its height or perpendicular from P. Now what is the area of triangle PQR? It is half into QR into PM. Now let me take PQ as the base. Then how will you find out the area? Here let me draw a perpendicular from R to PQ, that is RT. Now this area we can write it as half into PQ into RT. Now let me take an obtuse angle triangle PQR and I want to find out the area with the base QR. Now if you draw a line perpendicular to QR, from QR you cannot find out a perpendicular here in QR. So we have to extend QR to get a perpendicular. So we have to find out the area as half into QR into PT. That means here QR you extend to get a perpendicular PT in case of an obtuse angled triangle. Now go back to our proof. First let me find out the area of ADE with base AD. That we can write it as area of triangle ADE is equal to half AD into EA. Now let us take area of triangle BDE with the base BD. Again let me take area of ADE with base A. That we can write it as half into AE into DM. Now let me take triangle DEC. Now find out the area of DEC with EC as the base. Area of triangle DEC is equal to half into EC into DM. Now find out the ratio of the first two areas and the last two areas. What will we get? Area of triangle ADE by area of triangle BDE is equal to half AD into EN by half AD into half dB into En. Here half and half cancel, En and En cancel. So the remaining is AD by dB. This we can take it as equation 1. Now let me find out area of triangle ADE by area of triangle DEC. That is half AE into DM by half EC into DM. Half cancel, DM cancel. You will get AE by EC. That one you can take it as equation number 2. Now look at equation 1 and equation 2. Both the numerator of the LHS, that is area of ADE, area of ADE, both are same. Now look at the RHS. Here we have AD by dB and AE by EC. That is to be proved here. AD by dB is equal to AE by EC. That means this equation 1 and equation 2 are equal. Then you can say that AD by dB is equal to AE by EC if LHS are equal. Now numerator, both numerator are equal. Now you have to check area of BDE and area of DEC whether they are equal or not. For that you have learned a property in class 9. Here you have a parallel line. Now let me draw a triangle between this parallel line with base DE. Now let me take another triangle with the same base DE and between same parallel. Now let me find out its area. Here area of FDE is equal to 59 square units. Area of DEG is again 59 square units. That means both the areas are equal. Now if we change the size, you can see the area will be equal in all cases. That means triangle having same base and between same parallels are equal in area. Now look back to our proof. Here triangle BDE and triangle DEC both are having same base DE and between same parallel DE and BC. Therefore they are having equal area as we see before the property. That is here area of triangle BDE, area of triangle DEC are equal. That we can write it as, since triangle BDE and triangle DEC are on the same base DE and between the same parallels BC and DE, area of BDE is equal to area of DEC. Area, in short, AR we can represent. This equation we can take it as equation 3. Therefore, from 1, 2 and 3 we have AD by DB is equal to AE by EC. Hence, the theorem is proved. Let us have a quick look on this proof. First, we took triangle ADE, then find out its area with the base AD, then took BDE and with the base BD found out its area. Next, again we took ADE, with the base AE we found out the area. Again we took DEC and with base EC we found out the area as half EC into DM. Now next step we took the ratio of the areas of first two ADE and BDE. Then we found it is AD by DB and took it as 1. Next we found the area of ratio of areas of ADE and DEC. That we will get it as AE by EC and took it as equation number. Now we use the property triangle triangle BDE and DEC are on the same base DE and between same parallels BC and DE. Therefore, these two areas are equal. That we took it as 3. Now using 1, 2 and 3, we got the result, that is AD by DB is equal to AE by EC. This is the proof of basic proportionality theorem.